Hello everyone, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, The Future of Trace Management, presented by Anritsu. Our presenter today is Tom Elliott, Product Manager at Anritsu. At this time, I'd like to pass the presentation over to Tom.
Hi there, I'm Tom Elliott, and welcome to the webinar on the future of trace management. What we'll be focusing on today is trace management trends, particularly as it relates to in-building wireless trace management. Next slide. So, in-building wireless. Here's a little gotcha for you. 80% of mobile data is consumed indoors. This is not surprising, really, when you think about it. After all, that's where people live, that's where they work, that's where they shop, that's where they go to sporting events, and particularly in the colder climates, that's where they spend the majority of their time. So you can see down here that the macro cells, according to SNS research, they're growing, they're going to keep on growing through 2020, but the red, green, and the dark blue represent growth in small cell carrier Wi-Fi and DAS offloading from the macro cells. You can see they're something like 3 times bigger than the macro cell growth. And this is because 80% of the mobile data is consumed indoors. Macro networks alone can't support the demand. So let's take a look at the next slide now. Okay. Distributed antenna systems. That was part of the slide we're looking at the last time around, but on this slide, there's quite a bit of projected growth for distributed antenna systems, indoor antenna systems, whatever you want to call them, or DAS, IDAS, ODAS, particularly in North America and in Asia Pacific. In North America, it's being driven by competitive pressures for quality of service, it's being driven by regulatory pressure for emergency services, and it's being driven by large events, football, baseball, concerts, and things of that nature. In the Asia Pacific region, it's being driven largely by building density and high-rise buildings. Getting coverage wherever you are is a theme of this particular chart here. The next slide. In the United States alone, there's quite an ecosystem for both cellular and public safety support companies. There's over 500 support companies in the United States alone. There's service companies, staffing, training, hardware component, accessory companies. This is coming from a recent edition of the RCR Wireless Infrastructure Supplier Guide. Now, when we have this sort of ecosystem, one company doing work for another company, doing work for another company, it's often the case that the people actually doing the work, installing the antennas, installing the cables, installing the fiber, have to prove that they did the work properly so they can get paid. When I was learning math back in school, the teacher would always say, show your work. It's much the same here for this ecosystem of support companies who are doing work for other companies and ultimately for the network operators. They generally have to show their work. Slide 5, please. So, historically, 5 years ago, that's historical, I guess, in this business, when 3G outdoor installations were still going on, typically you'd see some RF cable running up a tower, you'd see a jumper at the top, a jumper at the bottom, an antenna, and they'd probably run a return loss, distance to fall to cable loss, maybe a PIM trace. They'd often have to photograph the installation, maybe take a photo of where the antenna was pointed. There'd be some documents. There might even be an OTDR trace or two involved in this. As we move towards remote radio heads, the number of deliverables maybe went down, but we're talking 25, 50, maybe even 150 traces per tower. This is something that's typically managed, well, let's take a look at the next slide. This is something that can typically be managed with a desktop application. Anritsu has line sweep tools, JDSU has JD Viewer, RNS has ZVH View, and there's others out there. These are all PC-based applications that basically deal with one trace at a time. And people would take the line sweeps in the field, and somebody back at the office would open it up and make sure the markers were at the right place, the start and stop frequency were right. They might rename it, save it under a new name. They might change the title or subtitle and put the limit line where it belongs. In general, paperwork. Now, when you're dealing with 25 to 50 to 100 traces, it can be done this way. When it gets into the higher volume, people tend to come up with custom solutions. These may be based on comma-separated files and Excel macros, but there'll be a custom solution of some sort. The desktop app sort of runs out of gas when you get over 100 traces per tower. Next slide. Now we move to the distributed antenna systems, where instead of 6 cables going up a tower, you may have 100 to 500 cables and antennas in one single system. So if we have a DAS systems come in either single carrier or multiple carrier systems, and let's just take a single carrier system as an example. We might want a return loss, a cable loss, a distance default, and a PIM for each cable. We might want to do a PIM and return loss for each antenna. There'd be some photos, maybe some fiber test. And when we put these cable segments together, we'll probably want to test them as a unit as well, some sort of a system test or a branch test. It's really easy to get 4 or more tests per cable or cable segment when you're doing this sort of thing. And when you multiply that by 500, well, even by 100, that puts you up to around 400 deliverables right there. But let's go to the next slide. When we go to the distributed antenna systems, we may be talking about a neutral host system. In this case, we want to make sure that it works in the US frequencies, at least in the 700 meg band, the 850 band, the 1900 band, the 2100 band, and so on. So take these 4, 5, or 6 tests per cable and multiply it by the number of bands you're dealing with. You might be multiplying by 3 or 4 frequency bands. You can easily end up with 10 to 12 tests per cable, plus test on branches and other assemblies. And the number of tests required gets so far away from what can be handled by a PC app. DAS systems may easily need 1,000 to 15,000 deliverables. The historical method of trace management, what we do with towers, just simply does not scale into a DAS environment. It's not what's needed. So what's happening as a result? Well, now we can go to the next slide. To understand some of this, I'd like to take a quick review of what's in a neutral host DAS. Now, I'm sure a lot of you listening to this webinar know what's in a neutral host DAS much better than I do, but for those of you who this is perhaps our first exposure, let's just take a couple slides to look at what may be happening here. This is a football stadium over on the east coast of the US, and you can see the stadiums there. The little blue square over on the left of the screen, that's a separate building called the hub, and that's where most of the signal conditioning equipment is. It's where the cells are, and it's where the cellular, the RF to fiber translations is. Okay, let's go one slide down. So running from that hub over to the stadium is a bunch of fiber. But inside that hub, in the upper right, you'll see there's rows of small cells. There's 52 sectors in this stadium. And this particular invitation you see in the upper left, they're running 2 bands, one at 700 and one at 1900, with 1 small cell for each sector. If you look in the lower right, you can see some macro cells that are being repurposed for use in this stadium. If you look in the lower left, I'm sorry. That was right. You look in the lower left, and you'll see some of the signal conditioning racks. And the signal conditioning racks are taking the RF output from these cells, attenuating it to roughly 100 milliwatts, and then they are modulating onto light. So we have a modulated RF signal being modulated onto the light signal, and the analog fiber is what goes over to the stadium. Next slide. Once we get to the stadium, we have FBDAs, fiber bidirectional amplifiers, that translate the modulated light back to modulated RF and then just amplify it, distribute it to the various antennas. And of course, there's a reverse path as well. After all, this is a cellular system. So in the lower left, you can see a couple of FBDAs on a plywood board there. The fiber is coming in the top, and coming out the bottom is the RF cabling, some splitters, and going to the various antennas. In the picture in the middle, you can see a plywood board with 3 sets of FBDAs. There's 2 for each branch, by the way, because this is a MIMO system for LTE. Okay, there's 2 sets of smaller FBDAs and 1 set of the more powerful 10-watt FBDAs there. You can see a bunch of splitters on the board, a bunch of cables, some PIM testers. There's a site master in there. And off to the right side of the picture, you can see the half-inch RF cable going off to the antennas. And then in the upper right, you can see an antenna in the studio level. That's the sort of thing we're talking about for a stadium DAS system, and I have this in here to give you a sense of the scale of the sort of thing we're talking about. Now, this was not a particularly big stadium. There's a lot bigger stadiums out there, and there's smaller ones as well. There's also hotels and coliseums and event centers. So let's go on to the next slide. Here's a diagram of one branch of an FBDA. This is FBDA 13 and FBDA 68 in our example. The yellow is the fiber coming into the fiber bidirectional amplifiers. Then jumpers are going out of there. And you can see there's a set of splitters on each side, and each FBDA is driving each antenna. That's part of the MIMO deal. You can see there's quite a few cables in here, quite a few antennas. If you take those cables and multiply them by 12, that's the number of traces you're dealing with for this particular branch, plus the test for the branch as a whole, plus the test for the antenna. You can see where managing this many traces, this many deliverables can quickly get out of hand. It can become really a big issue. Next slide. So here's a picture of a poor gal buried in paperwork. Now, this is something that came off of Google Images, and it's a little bit overblown, but I don't know that it really is. I've been in offices and network operators where I've seen 20 4-drawer file cabinets full of reports of this nature. The picture really isn't that unrealistic when it comes down to it, although I'm sure they'd be organized better than this, but it makes a point. So let's say you're a lead contractor and your sub has just delivered you a directory with 1,000 files, 1,000 traces in each directory. Now, when you're creating these traces out there in the field as a technician, it's real easy to get distracted. You'll go on a break, you get a phone call, someone talks to you, you have to move a ladder, and it would be real easy to say, do one test twice. It'd be real easy to type something wrong when you create the name. It'd be really easy to skip a test if you get distracted. So a lot of times people will organize these traces by directories. After all, that's sort of the Windows default, or the Apple default for that matter. And if you get a directory with 1,000 traces in it, well, it's supposed to have 1,000 traces and it really has 995. How are you going to figure out which 5 are missing? You're going to be there a while, aren't you? Or if you get this in paper delivery, traditionally what they do in towers is deliver PDF reports with 1, 2, 3, or 4 traces on each page. The story I've heard in this case is an RF engineer getting us 700 pages of PDF. Think of that, that's a ream and a half of paper. And he's looking at this, he's holding it in his hands, and I just have this image of the guy standing here going, what am I supposed to do with this? So what's happening here is a side effect of this trace management issue is test quality is slipping. It's not deliberate, it's not anything on purpose, there's just a lot to deal with here, and we people, our brains aren't equipped to deal with 100% quality every time, all the time. Next slide, please. So here's how people are adapting. When I'm talking to the operators and the contractors, I'm hearing that one thing that's happening is the project managers will sample the test results. And what you'll hear in this case is something like, you know, our techs are good, I trust them. And I don't argue with that at all. The techs are often excellent. But you know what? I tried testing a set of fiber a while ago. It was 4 bidirectional fibers. I wanted 1 VIP for each port, and I wanted 1 OTDR for each cable. And simply keeping my attention on that long enough to get everything done with the right name and the right time was tough. I'm impressed that things are as good as they are, but if you have a 5 or 10% error rate on your traces, and you sample them, and there's only one bad, I'll turn them in. And then your customer on the other end says, well, there's a lot here, I'll sample them as well. They have good technicians. And maybe their sample happens to find a 5% error rate. Now we get into this finger pointing, we need things done over, payments get delayed. All that sort of ugly stuff that happens. Okay, another thing that often happens, I've seen this in the industry, is a larger contractor will hire a software engineer to come up with a custom test solution of some sort. Often this will involve Excel and macros. Things like this, they can be broken pretty easily. Maintenance is required, and the people I've talked to often have programmers on retainers or for some way they end up paying them a substantial amount of money each month to keep things running. Another thing that's happening is a thrust for reduced testing. Maybe we don't have to test every cable. Maybe we just need to test stuff when it's all put together and worry about the cables if the full test doesn't pass. Sometimes this is an option. With other customers, it's not always an option. But this does increase the potential for expensive issues later. So there is potential solutions out there. There's several trace management systems out there. And I'd like to spend a little bit of time here taking a look at what this system might look like. And the first thing we need to do is take a close look at how traces are managed right now. And then we take a look at where the prospects for automating this workflow might be. So let's go to the next slide. So here's the existing workflow. We start out with, from the very beginning, somebody creates a MOP, or in Europe this is often called an LWI, local work instructions. And this sets the testing criteria. After that, we need to go design the DAS. An RF engineer will do this. This is IBWave has a very popular tool for dealing with DAS design. It's also sometimes done in Excel. And after the design is created, a test plan is created of some sort. There'll be a list of cables, or there'll be a naming scheme together with a MOP, or maybe there's something more organized than that, but there's a test plan, okay? Often this is an Excel workbook. It's used to assign work, it's used to record results. And if we're talking about 5,000, 10,000, 15,000 results here, these workbooks are massive. They can be massive, okay? And they do have the issue that numbers are often entered in there by hand. But let's go to the next slide. Now we're talking about configuring the instrument. The next thing is the guy in the field, or maybe an RF engineer somewhere, has to configure the instrument to be as quick as possible to use. What I've seen is a lead field tech that would create required setups for all the testing. He'd save them so he could recall them quickly. So instead of having to type in 10 different things every time he changes the test type, all he has to do is recall a setup and he's set up and ready to test. The other thing is a lot of instruments, and Anritsu in particular, have something called a quick name matrix. And what this is, it's name segments. So you can punch a button and put in cable 152, punch another button and put in the address of your venue or your sector number or something like that. At any rate, it makes it quicker to make your names, and it makes it a lot more error-free. But when you're dealing with 15,000 or so unique file names, even the quick name matrix can be a challenge. So after the instruments are all configured, the next thing to do with the installation and the test, I'm linking these because oftentimes the requirement is to test cables as they're built before they're installed, and then test cables after they're built as an assembly. So I can't help you much with the installation here. But as far as the trace management goes, we're talking about testing as you go, and the installation is normally not considered done until these tests pass. Okay. Common errors at this stage include traces that get duplicated, traces that are missing, traces that are misnamed. Sometimes the technician uses their own naming scheme, sometimes they use a required one. And sometimes they simply get misnamed. I mean, when you're talking about this many traces, that's really easy to do. I'd almost say inevitable. And there's also trace fails from external causes. For example, if you're doing a PIM test and your antenna has to be located too close to some rusty metal, well, you're going to have some external PIM, and that's just the way it goes. That may be, the decision may be made that that's acceptable. Okay, next slide. Then there's trace delivery. Once all the tests are done and the traces are taken off the instrument, they're normally delivered from the field worker back to a lead contractor. Maybe it's the project manager, or maybe it's the RF engineer serving as a project manager. There's a lot of ways to get these traces from the field back to the office: Dropbox, SkyDrive, Google Drives. There's a lot of cloud services used for these particular movements. They're generally way too much for email. The Stadium I showed you before, the files from that, 80% of the files from that, I should say, was about 4 gigabytes. That's not something you're going to pop into an email and send somewhere. But there's some sort of delivery method, okay? Because generally the customers are physically separate. They aren't in the same city. They aren't even in the same state, oftentimes. So then we go on to a pass-fail analysis. This is where the trace data is processed. What this generally involves is looking at the data, putting the data, a key value from the data, into a spreadsheet somewhere, making a link in that spreadsheet to the image, and doing things like that repetitively until everything's into the spreadsheet. Now, this is a place where macros in Excel can help a lot, but what I've seen so far, the pass-fail judgments are still often done by the Mark I eyeball. At some place, a person will sit down and scan through the results, looking for things that stand out as strange. It is good at catching stuff that's really bad. It's not so good at catching stuff that might be 5 or 10% or even 20% over. So it gets back to that sampling results things again, okay? It gets back to the pass-fail is approximate. And now we get back into the whole, well, I think it's good. Somebody else doesn't think it good. Now we have to start resweep some of these traces and payments delayed. Because when you have a crew that's gone out on site, they've got their lift truck out there, they've got their scissors lift, they've got their ladders, they've got all their equipment. Now they're off to another job. You're asking them to come back to a venue and re-sweep some cables. You got to schedule that. It's not like they can just drop what they're doing and head back there. They're on another job, okay? And then there's report preparation. Again, a lot of that's some manual work, as we mentioned, and a lot of people are using macros to help them out with this, or maybe some Visual Basic program. Next slide. Now, after all the report preparation, we've delivered the traces, we've analyzed them, we prepared a report. Now we got to get the report off to the end customer. Maybe it's a Verizon or AT&T or somebody like that, or perhaps it's a public safety job or it's a venue owner. But the report needs to be delivered ultimately. Again, we're back to something like Dropbox or SkyDrive or some other cloud service. At this point, there's a second pass-fail check because the end customer is saying, well, is this really what I'm paying for? Should I pay for this job? And again, it's the old Mark 1 eyeball and tends to be approximate, and results tend to be sampled. And if this customer is sampling a different set of results than the project lead, well, it can lead to that old finger-pointing exercise again. Hopefully the payment's fast at this point, okay? But the sampling can be an issue and can result in delayed payments. Next slide. So now let's talk about how this process can be simplified. On the front end, somebody's still going to have to create a mop. That's the standards we're doing the job to. Somebody's still going to have to design the DAS. And IB Wave has automated a lot of that. They have a lot of assist there. In the end, somebody's going to have to cut a check and make a payment. But everything in between is a candidate for automation to some degree or another. The automation candidates include field test, pass-fail checks, and the reporting, even creating that test plan up there. So next slide, if we would. Let's take a closer look at this. So starting up at the top here, create a test plan. When we have a DAS design, if it's in Excel or whether it's coming from IB Wave or some other design software, we know what we need to test. Wouldn't it be nice to have something you could take this list of cables and automate creating that spreadsheet with the 15,000 traces in it? Why not automate this? It'd make it a lot easier to share. Or the instrument configuration. We know before we start exactly how the instrument needs to be configured. We know the start frequency and the stop frequency for every single test. We know the type of test we want. We know where the limit lines need to be and the markers, and we know the pass-fail standards. Why not automate that? Installation and testing. Installing, we aren't going to automate that, okay? That's going to take robots, and we aren't there yet. But the testing, yeah. One-button testing. Remember, we have a test plan there. We have the instrument configured. We know exactly what the instrument needs to do. We should be able to have a button we can press on that instrument that says test cable 123 for return loss, test cable 123 for cable loss, or how about a button that just says test cable 123? Save the results. This will eliminate the file naming issues. It'll eliminate the missed test. It'll greatly simplify life for everybody involved. Next slide, please. Okay, then trace delivery. If our automation software happens to be a cloud application, well, delivering traces is a natural function of a cloud app. Anybody with a login, wherever they are physically, has access to those traces. And it doesn't matter if one person is in Mexico City and the next person's in Canada, or if one person is in Minneapolis and the other person is in California. It's going to work, and all of a sudden the distance stops being an issue. Pass-fail analysis in the instrument, yes, but pass-fail analysis in the cloud as well. This is where automation can really shine, okay? It double checks what's happening in the instrument. It eliminates the errors. and it can provide a dashboard that allows you to realize just where the job is right now while the techs are still there in the field. Report prep. Yeah, we should be able to prepare a report of some sort, something that's at least close enough to greatly simplify your life. Report delivery, again, that's natural with a cloud solution. And then there's that second pass-fail check that's being done by the end customer. It can either be done by the native report with some pass-fail in it, or you can allow the end customer access to the same cloud app that the project manager is using. If that's acceptable, it can work out well. Okay, let's keep on going. So, it turns out that Anritsu, among other companies, has developed a tool that does this. It's called SkyBridge Tools, and it's intended to streamline workflow. It allows you to create, test, and report without really having to do the typing. Okay? We can create a test plan from either a MOP or a local work instruction. Also, and we can do this with input from the IBWave cable routing report, if that's the tool you're using. It allows test sequencing, that is the one-button testing. And what you see in the picture there is one of our site masters, an S331L, and it has a one-button test automation menu up there that was actually created on SkyBridge, and it's running on the instrument. So you can say, run the test on cable 1, 2, 3. Automatic instrument setup, automatic file naming, pass-fail visible to the field tech while he's hooked up, even present absent. Have I done this test or I have not done this test? Visible in the field. Next slide. And on the report, again, here we have a spreadsheet. This is a CSV spreadsheet in this case that's been created from the tests that were automated in the previous step, including links to the final image. So in this pass-fail report, we have one line per test. One of those columns there is pass-fail. Key values are displayed. Test images are included. Next slide. So the benefits of this sort of thing, SkyBridge tools, we can greatly simplify workflow. We can eliminate field typing. We can eliminate field setup. We can eliminate duplicated or missing tests. We can greatly reduce both technician workload and the project manager workload. The techs will know before they unhook from the cable whether it's passing or not. Sharing traces suddenly becomes easy. Anybody with an account in wireless access can do this. Trace analysis is now done automatically. It's not done outdoors. It's not done in a hotel room somewhere. There's a lot more consistency. Everybody has the same MOPs, the same criteria, the same setups, and the same test. We all have the same playbook. Judgments become reliable. We have timely payments for work done. Next slide. So in summary, 80% of mobile data is consumed indoors. This has driven the installation of a lot of different solutions, DAS systems among them. And as DAS system popularity has increased, it turns out they have significant differences over towers. Contractors need to show their work. And when you have thousands of deliverables and industry-wide reporting issues, there's a problem here. The trace management workflow that we inherited from the tower build-outs is cumbersome. It really doesn't scale well, and it's ripe for automation. The solution? Anritsu SkyBridge tools can greatly simplify this workflow, help you create, test, and report on DAS system installations. Next slide. So I'd like to open it up for questions now.
Thanks, Tom. This is Kyle again. We've had a number of questions come in. So the first question we got, is SkyBridge tools compatible with IBWave Designer?
So SkyBridge tools can import the files from IBWave Designer, and it greatly helps in the creation of a test plan. The import along with a wizard allows someone to build a test plan.
Okay, great. We had another question earlier about the RF test tool. Does that coordinate fiber, PIM, photos, and other resources?
Yes, SkyBridge Tools is compatible with cable testers, the Anritsu site masters. It's compatible with fiber test, anything that uses the industry standard SOR file. It's compatible with PIM test. It can handle pictures, site photos. It can handle images, PDFs, and documents. And it can also deliver documents to the field if that's what's important for this particular job.
Okay, great. Next question that came in. With the SkyBridge tool, do you still have to test separate branches and components?
So testing separate branches and components is really a decision that's made at the MOP level. SkyBridge Tools works either way.
Gotcha.
It's flexible enough.
Next question. Will SkyBridge tools work with the 5-step job aid requirements?
SkyBridge Tools was developed with the 5-step job requirements in mind.
Okay, great. We have some other SkyBridge questions here. Will SkyBridge tools work with all vendors' equipment, or is it exclusive to Anritsu?
So SkyBridge Tools is not exclusive to Anritsu. It may work somewhat better with Anritsu, but in any case, it can upload images, screenshots, SOR files, and DAP files.
Okay, great. We had a couple questions about that one, so I think we just answered those. Will SkyBridge tools work on a laptop?
It'll work on a laptop, a tablet, even in some cases smartphones, as long as it has web access. And by the way, the instruments do not need web access while they're running test.
So another question we had was about Wi-Fi. So they don't necessarily need Wi-Fi connectivity to test cables?
That's exactly right.
Okay, great. So another question about compatibility. Is SkyBridge tools compatible with S331D?
So the older site masters, okay, you've got a serial port there. And getting data from a serial port to a laptop is your first step. And once there, if you convert the data, run it through line sweep tools, to simply an open and save, it'll be a modern format that SkyBridge Tools works with.
Okay.
So yes, it's compatible.
Great. Okay, looks like we have about one more question. So a couple of people asked about SkyBridge, whether it's cloud-based or not. Can you go into whether or not it is and how that all works?
Okay, yes, SkyBridge itself is cloud-based, and it uses Microsoft Azure servers. So we've got some big iron involved in this. They have centers around the world, which means you can generally get something that's relatively local wherever you are, and we have all these beautiful uptime guarantees.
Okay, actually, it looks like we got a couple more questions in. So can you go into the difference between SkyBridge and the Suitemaster's Pro and Pro Plus tools?
So SkyBridge is a tool that's targeted at DAS systems, and it's also a tool that our users will need to set up themselves. Suitemaster's Pro and Pro Plus is targeted principally at tower systems, and it's a custom turnkey solution.
Okay, great. And next question is, how much does the SkyBridge cost?
Excuse me, Kyle, I've lost you there.
I'm sorry. How much does the SkyBridge cost?
Okay, SkyBridge is it's going to run around $2,000 a year for 5 instruments. Okay, but of course, prices may vary. You can take that up with your local account manager.
Okay, great. That looks to be about all the questions and time we have right now. I want to thank everyone for attending today's webinar, The Future of Trace Management, presented by Anritsu. Our presenter today is Tom Elliott, Product Manager at Anritsu. Thank you, Tom.
You're welcome.